Hi, you guys. We're now going to be talking about another shortcut in triangles to show that triangles are congruent. So if you thought we were done with these shortcuts, guess what? We are not, which is pretty exciting. Now, the next shortcut is used in only right triangles. So this is very specific. It only works if you have a right triangle. Okay, and it's called the hypotenuse leg theorem. Hypotenuse leg. Guys, so if we have two right triangles and we know one leg is congruent as well as the hypotenuse, then that is enough information to show that triangles are congruent. But let's take a closer look at this. So we know if these two are right angles that all right angles are congruent. So angle B and D are congruent. And if we look at the markings on this triangle, let's see if I go around my triangle to see how this is marked. I have a side, then a side, then an angle. Holy hot dog. The hypotenuse leg theorem is using the SSA postulate, which we know is usually not allowed. Now, SSA is allowed if you have a right triangle, and only if you have a right triangle. Okay, but we're not going to call it the SSA because remember, that spells a bad word, and we're not about bad words in math, okay? So the hypotenuse leg theorem is when a hypotenuse and a leg are congruent between two right triangles. So instead of calling it the SSA postulate, we're going to call it the hypotenuse leg theorem so we don't say any bad words. Okay? Now, the reason why the hypotenuse leg theorem works, so you're like, Miss Long, I'm pretty sure you told me that SSA never works. Well, it only works in a right triangle, and I'll explain why. Okay, so what nifty formula do you use to solve for the sides of a right triangle? Holy hot dog, you guys. That would be the Pythagorean theorem. Okay, so if I have a leg and I have a hypotenuse, that means I have an A and a C value, or a B and a C. Remember, the legs you can either use as A or B. Okay, so if I have A squared plus B squared equals C squared, okay, if I have the C and the A, if I subtract my C from my A, I will get the same answer for the B, or the missing leg. Okay, so if I know two of the sides of the right triangle, and I know they're congruent, using the Pythagorean theorem, when you solve for the third side, they will be the same exact value. So again, this can only be used in right triangles. It's the hypotenuse leg theorem. And again, when you solve for that final side, they will be congruent. Okay? So, if we look here, if I mark in this extra congruent side, because I know if I use Pythagorean theorem, these two sides will be congruent if I have two legs and a hypotenuse that are congruent. Okay, so if we look here, let's look at the markings of this triangle to see other ways these two triangles are congruent. Well, they are congruent by side, 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 side. Also, since we know right angles are congruent, these two triangles are also congruent by side, angle, side, side, angle, side. Okay, so technically, if you were to mark in the third side as congruent, which we already know is congruent because of the Pythagorean theorem, the triangles would also be congruent by side, angle, side, and side, side, side. And again, this only happens in right triangles, so be careful. Okay, so instead of having to go through the process of finding the final leg through the Pythagorean theorem, which we already know it will be congruent, instead of having to go through all that, you don't have to do that. Okay, you can see if you spot two right triangles and you see that two legs and the hypotenuses, or whatever the plural is for hypotenuse, I'm blanking right now. If you see that their hypotenuse is congruent as well as their legs, you can just say the triangles are congruent by the hypotenuse leg, or the H to the L theorem. Okay, so again, it's kind of like a shortcut within a shortcut, which is pretty cool. It's a shortcut so you don't have to go through the process of marking the third sides congruent to show triangles are congruent by SAS and SSS. So it's like an ultimate shortcut. And again, this can only be used in right triangles, so watch yourself. Okay, so using the hypotenuse leg theorem as well as their other shortcuts, so don't forget about SSS, SAS, AAS, and ASA, we are going to show that the triangles are congruent. But in this case, we're kind of trying to look specifically for HL, but if the HL theorem fails us, we will use one of our other shortcuts, hopefully, to show triangles are congruent, because we really want to prove they're congruent, you guys. Okay, well, let's get going on example 1. Let's go. Okay, so again, we're going to state if the two triangles are congruent, and if they are, we're going to state how we know, which we're hoping they're going to be congruent by HL. If not, we're going to try one of our shortcuts. So let's see. Okay, so when you're using the HL theorem, it is required to show that your triangles are right. If they are not right, you cannot use HL, so watch yourself. The demon cats will get you if you use HL in a non-right triangle, so be careful. Okay, so looking at these two triangles right here, how do I know? Do I know that these are right triangles? What does it mean to be a right triangle? Precisely, you guys. You guys are so smart. Guys, what it means to be a right triangle is a triangle with a right angle. Which, guess what? Triangle HAT and triangle OLW, hat now, board slapper. These two triangles have a right angle in it, which means they are a right triangle, which is pretty cool. Okay, so the first thing, I must establish that these are right triangles. That's always step 1, okay, which I've done that. Okay, so I'm going to say triangle HAT and triangle OLW are right triangles. And my reason for knowing that is because that's what it means to be a right triangle. So by my definition of a right triangle, sorry guys, I did not space this out well, so don't be like me and leave more space. So this is because of my definition of a right triangle. Okay, so I have established that these two bad boys are in fact right triangles. Okay, so now that I know they're right triangles, now I can be looking to see if there are two legs that are marked congruent and then two triangles that have the same exact markings on the hypotenuse. So let's see here. I know for a fact that H to the T is congruent to L to the O. And I know that because it was given to me, which, sorry, I know this is all running together. Sorry. Guys, and in my triangle, this is going to be a leg because it is the side of a right angle. Guys, so I have a leg that is marked congruent. So let's see if my final marking is a hypotenuse. If I have a hypotenuse and a leg marked congruent, then the triangles are congruent by the hypotenuse leg theorem. So let's see. I know that H to the A is congruent to O to the W, also because it's given to me. And which side of the triangle is HA and OW? Well, these are the sides that are directly across from the right angle, which means we have found a hypotenuse. So this is a hypotenuse. So guess what, you guys? I have a leg and I have a hypotenuse. So that means my two triangles are congruent by the hypotenuse leg theorem, or the HL theorem. Holy hot dog, right? I know, I'm so excited, I'm just going to throw my pen down. Whoa. Okay, so now I need to write my triangle congruency statement, which you guys are pros at. Okay, my first triangle, I'm going to say triangle HAT is congruent to triangle. So if I go HAT, okay, I go from 2 tick marks to 0 tick marks to 1 tick mark. So 2 to 0 to 1. So 2, 0, 1. So I want to go 2, 0, 1 in my other triangle. So let's see here. If I go from 2 to 0 to 1, that would be OLW, or OWL. So 2, 0, 1. OWL. Which I'm glad it worked out. I wasn't planning on them spelling the correct words when I wrote my triangle congruency statement, but it ended up working out. So there you go. And I know they're congruent by the H to the L theorem. Holy hot dog, right? Well, that's it for example 1. Let's get going on example 2 in a moment.